Okay, thanks very much. First time I've spoken in a ballroom. So what I want to do today is this. I gave a talk at IAVC in 2008 in Reykjavik, and this is a sort of updated version of that. And it is 20 years since I got the NERT grant to make Tephrabase, so I thought it was quite a good opportunity to sort of show how it's developed, and then at the end of it, to show you some of the features of it, and then at the end of it, just to show some of my thoughts about how databases should develop. So the people on this, Andy Dugmore, who would be here but he's on holiday, Richard Streeter, who's at the back because we're using his data for some new changes and additions to it, and Dale Cameron, who was a master's student at Edinburgh, who did some quite fancy things which we're going to incorporate into the database in the near future. So the first time in Edinburgh we started thinking about a database was back a long time ago in 1990 at a International Tephra Studies meeting that we had in Edinburgh in 1990. And from that was some initial ideas of a database. I do remember going to Aberystwyth in the early 90s, and John Westgate was there, and Andy Dugmore and I were, and you were telling us about, data, it's just a nightmare, you get so much data and things. And I remember that you, on the ICPMS, had a little card with a little pile of sorted glass on it, and that was where the ICPMS was in the early 1990s. So from those discussions with various people, we decided to put together a NERT grant proposal, which we put in 1994. So the project began in 94, and the first version of Tephrabase was released in 1995, and it's been running since then. And this is just a little picture. I don't have any of the files from 1995, but I do have them from 1996, and that was when the internet was grey. It was the default colour for the internet was grey in 1995. So this is the current version, which if you go to it, you'll notice it's changed quite recently because this meeting was a great stimulus to actually improve it. And so I've changed it. And one thing that's interesting out of this meeting is I'm going to have to do some more changes because some of the assumptions, for example, that nearly all the Tephra you find in Northwest Europe come from Iceland are obviously from Jill Blunkett's talk is actually not correct. It's a minor change. So what I want to do is just go through some of the main features of this and then just to talk about some of the new things which are not actually publicly available at the moment, and then just finish with some thoughts about it. So Tephrabase is a relational database. It's in Oracle, but it could be in MySQL. It could be in any relational database. And this is just a very simplified entity relationship diagram for those who know about databases, just showing the relationship between some of the tables in the database, just the main tables. There's quite a lot of tables. There's also a lot of other tables that are connecting tables together, lookup tables and things as well. So these are the main things that we're talking about. So obviously every Tephra sample has a location. It has a profile because there may be multiple profiles at the same location taken over different time periods, for example. And then we obviously have Tephra layers. So you have Tephra layers in a profile. And then there may be some subunits, and I'll come on to that when we talk about Lacasse. And then there's geochemistry. So originally, Tephrabase always had geochemical data associated with the Tephra layers. Recently, through the work initially with Lacasse Tephra, that's not necessarily now the case. So the Lacasse data, some of the Tephra layers in the database have geochemical data, and it tells you, and you can go to it. A lot of them are just where people have found it and identified it as being Lacasse. And then there's a whole variety of other stuff. There's historical dating, because in Iceland, where this all started, we have a fantastic historical Tephra record. And there's things like geochemical radiocarbon dates. There's details on volcanic systems, eruptions, and physical properties, which is something which I'll come to, which we don't use very much, but has always been there. You can put in an awful lot of detail about a Tephra there. There's all this metadata that we've been talking about that's important. And then references, there's a reference database, and all the data is linked to references so that people can acknowledge the source, and information on probe conditions for analyses. So this just shows here the structure of a database. So it looks a bit fuzzy to me here. But basically, again, if you're building your own database, please do use, if you want to use this as some sort of help in doing this, it supplies you with lots of information on the structure of the tables, what's actually in the tables in the database, and that's always been available for people to look at. So I did some, last week, I did some searches on the database to find out how much data is actually in there. So there are 3,274 Tephra layers in the database, of which most of those are from Icelandic. Okay, most of them are Icelandic, and then there's 437 deposits of lacusei, which are described. There's 83 discrete Tephra layers. Obviously, the Tephra layer is found in many locations. That's what makes up that big number. And there's 764 sites within Europe where those are found. And those are the countries that are represented in Tephrabase at the moment. There's a few radiocarbon dates, and there's over nearly 3,500 geochemical analyses. I've also done quite a bit of work in Mexico, central Mexico, and my data from that is in there as well. So there's data from Mexico, mainly from around Mexico City, Toluca, and Michoacan is in there as well. And there's just 2,500 references. This is just a map, just to show you. So we've always been using mappings. We used very odd maps at the start, but this is just showing the location of all the European locations where Tephra are found. And you can see the lacusei Tephra dominates in mainland Europe, and then we've got mainly Icelandic Tephra found elsewhere. This just zooms in to show you the location of the lacusei Tephra, and I'll explain that in a second about how that came about with Felix Ryder. And this is the Mexican Tephras, which are based around, and we saw some really good talks yesterday about the tephranology around Mexico City and then across in also Michoacan as well. So if you want to search for Tephra, really it's divided into several bits: European, Iceland European bit, there's a lacusei bit, and then there's the Mexican bit. So just seems a sensible way to divide up the information that's actually in Tephrabase. So you can go in and you can search on location. You can, for example, show me all the sites where Hecla 4 is found. You can do that. You can search in geochemistry. So you can say, show me the geochemistry of Hecla 4, and it will just produce a table of all the geochemical data. Or you could go to a particular site and look at the geochemistry of the site. And you can search on date. You can look for eruptions, you can look for some information on volcanic systems, and there are links through to the Smithsonian, and you can produce maps. So just a site search here, so you can go through and search for Tephra layers in Iceland, so it produces this nice map, and then you can just click on the site. So I clicked on the site here from a paper that we did a few years ago, and it lists you all the Tephra layers found in that profile. And if there's geochemical data available, there's a link to the geochemistry of that Tephra layer. It tells you some information about the Tephra layer and obviously the reference where it's come from. And this is just the geochemistry. So you could, if you want to download that, you can click on the download button. It will download a tab delimited file, or you can just highlight the table and copy it into Excel. And again, everything is linked. So you've got information there about the probe conditions that, this is important information to know, the probe conditions that were used to analyze the Tephra. And at the moment, the Tephra analyses that are in Tephrabase are major element and minor probe analyses, but there's no reason why there can't be other things such as laser ICP-MS, ion probe, or whatever you want to use. So you can search for the geochemistry of a layer as well. So here we've got Mr. Hecla 4, so there's 618 analyses of Hecla 4 in Tephrabase, and this just lists them all. And these are from anywhere that Hecla 4 has been found and analysed, and it's got the information, the references, and things there as well. You can also search very, very simple. Well, I've got a Tephra layer that's got a particular geochemistry. It's very, very simple in that you just you can choose your oxide here, and you can be between less than or more than. So here I put between 45 and 50%, and obviously it gives you a list of all the basaltic Tephras that you found here. And then you can obviously just go and get some information. This is Katla 1500. So it does have that quite a simple way of actually searching for geochemistry, but that's something we may want to talk about, doing a slightly more sophisticated way of searching for geochemistry. Now, of course, databases are great. You have to use a bit of common sense with this, okay? So there are lots of analyses in here where people have put it in, say, for 1104, which is a silicic eruption, and there are some basaltic analyses that have sneaked in there as well, okay? It doesn't mean that 1104 produced basaltic Tephra, but it means the layer that someone analysed had that in. So it doesn't give you the answers here. This is always interpretation. It's up to you to make a decision what you think about the quality of the data, which is something, again, which I think we'll be discussing, because some people I know feel that there should be some arbiter who decides that only good data goes in. And I don't really think that's correct. I think we really need to be thinking about the database as being a record of what's being published. Remember, everything's been peer-reviewed before, and I do think that there has to be some common sense with this. These databases are a tool to help us work out what our Tephras are and what other ones are, and it's not something that having someone deciding what goes in and what doesn't is quite a dangerous route, I think. You can search on date here. So in Iceland, we have this amazing historical Tephra record, where many Tephras are known to the minute that they occurred, certainly within the year, and that allows us to do some really quite impressive things. The work that Richard Streeter was doing in Skaftatunga in Iceland is a good example of that. So here we've got a search between 1100 and 1300, and it just produces there's 3 Tephras here, 1104. There's obviously there are more than this. It's just that's what's in Tephrabase: 1104, 1158, and 1300. And you can look, okay, where's 1104 found? And then it can give you some information about the eruption that I put into the database here. So, and this varies obviously on the amount of information varies depending on the Tephra layer, on the eruption. You can search on radiocarbon dates, so there are 44 radiocarbon dates in there as well. So this shows you layers deposited before 500 radiocarbon years ago, and you can click in here. So we've got the Vede Tephra, and then this is the radiocarbon dates associated with the sites, and it will tell you here the depth of the Tephra layer and also the depth of the radiocarbon date, so you can see the relationship between the radiocarbon date and the Tephra layer. You can also search on volcanic systems here, and it gives you information about the volcanic system, and there's also a link to the Global Volcanism project as well. It will tell you information about particular eruption here, and this lists all of the, for example, eruptions of Katla that are in the database. So the Lac-Assay, so these conferences are great, and the best thing about these conferences is meeting people when you're having coffee and things. And at IAVC conference in 2008, I met Felix Ryder, and we had a little conversation, and he said, I'm building my own access database of Lac-Assay, and that's not very good because it's going to be a bit static. Would you be interested in being involved in putting it on Tephrabase? And I said, yeah, okay. So we put this together. It's a paper published in 2011. They have some new data and things as well, new sites. So here we've now put this all together, and I was pleased. So this just shows you here. This shows you, you've already seen the sites where all of the Lac-Assay data is. This map just shows you the sites where there's geochemical data. So you can choose to show all the sites, or you can choose to show the ones with geochemical data. And this is a list of the sites here, and obviously there's hundreds of them all over the place. And this is one particular site here. And what's interesting about this, and this made me use some tables that I hadn't used before, or they existed from the beginning, and I need to just go here. So here we've got subunits, and so these are the Lac-Assay Tephra has some very discrete subunits which have been identified in many places. And so here we've got, the little thing disappeared. Right, I'm just going to, so here. Okay. So these are subunits, and each of those has been geochemically analysed individually. So if you want to look at just the geochemistry of a subunit, you can just click on that, and you can look at the geochemistry of that subunit. So here is the MLSTC unit in Darden, and you can just view that, again with all the geochemical information available. Or you could just look at all of the data from that site as well, of the Lac-Assay Tephra. So this is quite good, actually, because it made me do things that I hadn't done before with Tephrabase. That was good. And there's a paper, you can read more about it. Just the Mexican stuff, just to show there's a slightly reduced number of searches. I need to add some more information to this. But this just shows you a list of Tephra layers that have been found, that we found and analysed. And that just shows the location here of where the upper Toluca pumice has been found. And again, geochemistry available to look at, to download. So this is my nice filing cabinet picture. can't believe I spent time trying to find a nice filing cabinet picture. So databases are great. So you can put information in them and you can find out, what's the geochemistry of this, where's this found, and that's fantastic. One of the things that we've been trying to do in Iceland with Andy Dugmore, Richard Streeter, and other people is actually using the Tephras for more than that, trying to understand things such as landscape change, trying to apply them to geomorphological change. What do they tell us about the environment, people's interaction with the environment? So what we did in the last few years is actually we had a couple of master's students do some projects to actually see what information we can pull out of Tephrabase that's like added value to these Tephra layers. So Dale Cameron did a project a few years ago, and it was using Richard Streeter's data, which you can see in this recently published paper. And so basically, Richard did over 200 profiles, mainly to the east of Middlesjökull, which is here. And that's where Katla is, beneath there. And the great thing about Skaftatunga is it has a really good historical Tephra record. So Richard dug 200 profiles. There's about over 2,500 Tephra layers found in those 200 profiles. And that gives us a really dense historical record. And it was sort of very, very well dated. He dated a couple of Tephra layers better than they had been done before. And what we decided to do was really nice if we could actually try and develop some tools that would actually, in this circumstance, which I know is quite specific to Iceland, would allow us to do some things. So one thing you can do is this actually, you can select profiles, several profiles. So the map goes up there. You can select which profiles you want. And it automatically draws you a stratigraphic profile with everything at the right depth, which is something that is quite tedious to do by most other means. So here we have the Tephra layers here, and we have their names just next to the right level. And everything is at the correct depth and everything as well. So that's just something that we will make live on Tephrabase in the near future. Something else that we can do as well is we can look, one of the things in Iceland we can do is because it's the soils in Iceland are windblown, if you have excess soil accumulation, that means the soils are being eroded from somewhere else. So sediment accumulation rate can be used as a means for looking at erosion. And anyone who's been to Iceland will know that Iceland, since people got there, has suffered horrendously from soil erosion. So this is a rather tedious process, usually, to actually produce diagrams and calculate this. But by simply selecting which profile, it will automatically just calculate your sediment accumulation rate between dated Tephra layers. Just at a touch of a button, it just produces this. So there's a couple of ways of doing this. Here we have the dated Tephra layers, and the sediment accumulation rate in millimeters per year is produced in between them. And you can also produce these. These are created here. And this is, again, sediment accumulation rate against time. And obviously, the steps on the x-axis are where we have dated Tephra layers. So the more Tephra layers you have, the better for that. So that just shows you that this is incredibly time-consuming to produce normally. But this just shows that databases can be more than just repositories of data. You can actually get added information out of those databases. And we also thought about phone apps. What else could we do? It'd be quite useful to know, well, what Tephras can I expect to find where I am now? So we had a student produce, and it wasn't ever actually sort of put into the field, but when you're designing a phone app, you have a virtual environment, programming environment that pretends it's a phone. So the principle was shown. So Howie here did a project, and basically it allowed you to say, well, I'm here. Within this radius, what Tephra layers can I expect to find where I am? And it looks at all the Tephra layers around where you are, and it calculates. It says, well, I think you're quite near this profile where you find this Tephra, or this Tephra is quite a long way away, so that's a bit unlikely. And it produces a hypothetical list of Tephras that you could expect to find in your profile. So this is something that we'd like to develop more. And obviously, again, that's a field tool. You can pre-download everything because you may have no data reception where you are in the field into a little database that's on the phone. Again, that's a tool that we could develop more, and I'm sure there's other people probably thinking of similar things. So just to finish off the talk, I've got 3 slides to finish off. I also did a search on Google looking for reflections of volcanoes and came up with this one. This is the best one I could find. This is how I was spending my time last week preparing this talk. It's a really nice picture. So, reflections on Tephrabase. So it's 20 years of running this database. So let's be positive at the start. So let's just think, well, it's still there. It works. It's been added to. That's good. It's got a large number of sites and geochemical analyses. You can download the data, which you could do from the start. search on geochemistry if it's somewhat simplistic. I was really pleased that at that meeting we had the lack of say data. Again, that was just, one of these chance meetings with someone at this sort of event, and then you develop contacts and things as well, and that's really good. And I'm also really pleased that we're now thinking beyond just a simple database and actually thinking about, well, what can we do with that data that's in the database? So it's an expanding resource, but things could be done better. So let's just think things that could have been done better. So there's a lot of data not in there. So if you look at Graham Swindle's papers and look at Siobhan Davis's papers, there's a lot of stuff there that I haven't put into database because I've not had the time to do it. So there's a lot of information that should really be in there that isn't in there. Data entry isn't really being sorted out. It's a bit clumsy. There's some tables there's a form you can fill in and you can send an Excel spreadsheet, and I got to load it up. So that's one thing that would be quite good today, to learn about better ways of entering data into database. I have other systems that I've developed for other projects where we have allowed people to log in and upload data. That's not the issue. I'd just like to know. Technically, I know it's possible. It would just be interesting to see the different ways that that's done by different people and what people think is a good way of doing that. Which means there are gaps in data and delays and things which are not really acceptable. All of us need to, and we've been talking about this all the way through, all of us need to include more data about our Tephra layers, and we're the same as well. So there's limited extra data about that Tephra layer that's in the database that should really be included. There's a big lack of trace element data. That generally reflects the lack of trace element data that's been collected in Europe. But again, there's no reason that can't be. The tables are there. There's no reason that can't be included. And also, the other thing we should be doing as well, which we're going to surely be talking about today, is linking databases. It's not difficult to do. You need to have some common standards, some common fields, and that sort of thing, but there's no reason that these can't be linked together. You don't need a world database. You need to have databases linked together. And this is not a difficult thing to do. If you're going on holiday, Trivago will search through millions of databases and tell you which is the best room to go to. So this is not a complicated thing to do. The best price and things. So these are things that we should be thinking of. And this is great opportunity, and I've really enjoyed the last few days here. So just to finish, and this actually is very similar to the slide that I showed in 2008. So basically, to encourage other people to develop databases. I know these are being developed now, and that's good. It is quite surprising how long it's taken for these things to take off. So we need some common standards between databases, or at least ways of converting to common standards between things, so we can communicate between databases. Integrating systems, easy uploading and retrieval of data, and the uploading bit is particularly weak on the Tephrabase. And also just encouraging responsible use of data. One thing to remember is that all this data is becoming available. We need to use it responsibly. And people may be nervous of putting data on databases, but if they can see it's going to be used responsibly, hopefully people will not have so much of a problem with that. And also just use it innovatively, use it in ways that you haven't thought before as well. That's a really good message to take home as well. Okay, thanks very much.
Using statistical correlations in a database. What's your philosophy about that? That's a good idea or bad idea?
I did find yesterday's discussion quite interesting about that, because that's been going on for quite a long time. I remember in the 1990s there were several papers that were produced by people saying that really being critical of people who were not using statistical things. And then I just noticed that really in all the discussions we've had today, so the last few days, there's been no, apart from the specifically we had about statistics just today, people have just been comparing plots. And that's the way that I tend to work. In my PhD, I did use principal components and analysis on the North Atlantic pumice that I was doing for my PhD. And it did confirm what I already knew from looking at the graphs. So I did use that. It's the sort of thing you could build into these systems. You could allow people to, within a database, mathematically, it's not, it's very, very simple out. There's lots of code out there. You could do that. So this is the sort of thing you could build in. Yes. So I don't tend to use statistics very much. Maybe I should use more. There's all sorts of issues about, when you're using statistics, about the fact that a lot of the statistics require the data to be independent, and of course it's not independent. sort of increasing something else means to decrease in, so there's lots of issues with the statistics. So it's certainly something that I do think we need to be using it more. That's the thing, but we need to use it quite carefully as well. And also, you need to. I think the point you were making is that you need to use some common sense here. This is just a tool. You can't press a button and get an answer and say this is this Tephra. We need to be using I think Christy was talking about, we need to be using a lot of information. We need to be using the full suite of information, stratigraphic, position. You could have a perfect match on geochemistry, but be several thousand years difference. So you need to be using common sense, I think.
Tephrabase.
Oh, it don't work.
Hello?
Hello.
Hi. Tephrabase looks really, really cool, especially when I work in Alaska and think, gosh, Tephra Databases would be really helpful. I mean, you demonstrated some of the amazing things that you can extract from a very well-maintained database. Not that I'm lazy, but I don't really like the idea of having to reinvent the wheel. Has there ever been any discussion about turning Tephrabase from just a regional database into an international database that goes way beyond just Europe and obviously the few sites from Mexico that you've put in?
No. No, that's something I think that's a really interesting thing we can have a discussion about later on. I think I mean, that is a possibility. Yeah, that's a possibility. But there is other developments as well that have been happening as well. So I don't know a lot of detail about these other databases that have been developed elsewhere as well. So yeah, I mean, that's something I think we should discuss. Yeah.
Then I have a second question.
Oh, it's greedy.
Since I have the microphone. Databases are only as useful as long as they're being actively maintained. Mm-hmm. After they are, the people that are overseeing them move on to other projects, they start to decay and things stop working. What kinds of plans do you have for extending the longevity of Tephrabase?
Well, that's another issue that we were discussing and we're going to talk about as well. So sustainability of databases, which I think is probably on your list of things to... Yeah, so there is an issue with that, and there is no long-term plan for this, other than it's been going for 20 years and it's maintained at the University of Edinburgh. University of Edinburgh does actually hold quite a lot of big data sets as well and has a big infrastructure for that as well. So one thing that I'm thinking of doing is maybe transferring the database from our School of Geosciences to Edinburgh University's central data centre. And that's something that I've just joined a data group within Edinburgh University. So there are quite big data sets held at Edinburgh University. So this is something that I am thinking about. But I'm not planning on dropping dead just yet. So...
Thank you.
That's okay.
Yeah, actually, along the same lines, I have a database for the monocraters, and it would be really neat to talk about these common standards. One thing that you can do without having to reinvent the wheel is you can actually output the structure of the database from any regular SQL database, and that could potentially be used as sort of the standard that we could use as a model.
Yeah, I mean, you could do that. Yeah, so I mean, I've always had the tables have always been there to show people, but that's not. That's not easy to manually do things. But no, it could be done like that. And I'm quite happy for people to use the structure and things.
Yeah.
It's not.
Yeah, dumping the structure is trivial.
Yeah,
so yeah.
Just a brief comment to that. I mean, there's these internal structures that each database has have to be in some way always mapped to data standards that are evolving worldwide. So that, I think, needs to be kept in mind, that we develop sort of the internal Tephra standards and so on, but they need to, in some way, fold into the bigger infrastructures that are developing. And this mentioning here of web services is important because they can sort of harmonize the data. You don't need to necessarily have the same exact data structure in every database. The communication happens through these services. And so you don't have to worry too much.
Yeah, it makes it easy, doesn't it? I mean, it's not as complicated as it seems. But I think you were just saying it just helps when you're building your database to have a structure to build it around, don't you? Yeah.
Do you have any plans to add in the physical volcanology in addition to the chemistry you have, like grain size or density correlations with the chemical samples?
Yeah, well, there's already, if you go to Tephrabase, you will see there's a table with loads of information about that in, and it's never ever had any data put into it. So it does have the capability of doing that. It's just that that's not being put in.
I'm
So
happy to
yeah,
help.
I mean, I had that idea 20 years ago, and it's never done because a lot of the crypto Tephra stuff, that's not the information. It's different to working close up to the volcano in proximal areas.
Just back to the statistics. So the University of Alberta database has about analyses on about 1,500 samples. And when we're searching it, we use a similarity coefficient, but as a search tool. And we've actually integrated silica standard deviation into that as well.
Mm-hmm.
So one of the problems, we're always often dealing with unknowns. And when you start getting 3,000 or 10,000 or 20,000 data points.
It just helps
It's actually a very useful tool to help you narrow down your searches.
Yeah.
So it used as a search tool, it can be very useful, especially if you do something like integrate the standard deviation of the silica, which can really throw things off. So I don't know how easy that would be to put into a database like this, but it's
I don't think it's that difficult, actually.
Yeah.
It's doing maths within these things is actually quite easy. It's not. There's lots of additions to these programming languages like Python and Perl and things that will go off and do the maths and things. I don't think it's that complicated.
All right, let's move on. We have a couple other talks, and I'm sure we'll have some more discussion that goes with those.